Okay, let's dive right in. We're about to get into one of the coolest, most clever ideas in all of modern AI. It's a concept that shows us how machines can learn to stop just looking at things and actually start creating them from, well, basically nothing. And I mean, this isn't science fiction anymore. There's a technology called a Generative Adversarial Network, or GAN for short, that can do exactly this. It's capable of generating brand new images that look so real it's kind of shocking, turning a simple sketch into a detailed picture, or even dreaming up a human face of a person who has never existed. And this really gets to the heart of the mystery, right? I mean, it's one thing for an AI to see a photo and say, that's a cat. But how does it learn the very essence of catness so well that it can just create a totally new cat from scratch? How does it make that leap from being a student to being an artist? Well, the secret isn't some single genius-level program. The magic actually comes from a brilliant competition, a kind of high-stakes game between two dueling AIs, two neural networks that are pitted against each other. Now, to make this super easy to wrap your head around, let's just think of our two AIs as a couple of characters. First, you've got a master art forger who is trying to create the most perfect fakes imaginable. And second, you've got a super sharp detective whose entire job is to spot those fakes. So let's break down the players here. First up, you have the generator. That's our forger. Its job is to create new, totally fake images, starting from just random digital noise. Its one and only goal is to get so good that it can fool the detective. And on the other side, you've got the discriminator. That's our detective. Its entire mission is to inspect every image it sees, real or fake, and get better and better at telling the difference. You can see how they're natural enemies. So this rivalry, that's the engine that drives this entire process. It's this really cool concept called adversarial training, where you basically force two systems to constantly compete. And in doing so, they push each other to become absolute masters of their craft. And the logic behind it is just, it's simple, but it's brilliant, as this quote gets at. By creating a true adversary that is constantly poking and prodding at the learner's weak spots, you force the learner to get stronger and patch up those weaknesses. And, unlike a human, an AI doesn't get frustrated, so you can just keep this up relentlessly until it improves. So this training cycle works in a continuous loop, just like you see here. First, the forger cooks up a new image. Then, the detective takes one look and calls it out. Fake! But here's the really clever part. The forger doesn't just get a pass-fail grade. It gets specific feedback on why it failed. That feedback helps it improve for the next round, which, of course, forces the detective to get even smarter to keep up. And they just do this over and over and over again in a cycle that makes both of them experts. Okay, so at the very start, the forger is, well, it's terrible. The images it makes are just a mess, like total random noise, basically TV static. The detective's job at this stage is super easy. It sees a real, perfect photo of a cat, and then this blob of noise, and it's like, yeah, not a tough choice. But with every single round, the forger gets a little bit smarter. It starts making vague shapes, then maybe something that kind of looks like an eye or an ear. And this whole time, the detective is being forced to sharpen its own skills. It can't just look for blobs of noise anymore. Now it has to analyze things like fur texture, or the exact placement of whiskers, or the glint of light in an eye. So what's the end game here? I mean, how does this competition actually finish? When do we know that the forger has finally become a master? Well, the whole process reaches its grand finale when the forger gets so good at its job that its fakes are indistinguishable from the real thing. At this point, the detective is just completely stumped. It's basically just guessing, flipping a coin. It has only a 50-50 shot of getting it right. So at that point, when the detective is just guessing, the generator has officially won the game. The training is done. We can actually just thank the detective for its service and set it aside. We now have a master forger that can create an endless supply of brand new, totally believable images whenever we want. And this is where things get really, really interesting. What is actually going on inside the mind of this generator? Is it just a super sophisticated copy and paste machine, stitching together pixels it's seen before? Or has it developed a genuine conceptual understanding of what a face, or a handbag, or a cat really is? To figure that out, we have to look under the hood. You see, the generator doesn't think in pixels. It builds this amazing internal map of concepts, an idea space, that we call a latent space. And by exploring this map, we can find some mind-bending proof of actual understanding. Think of this latent space like a giant, super organized library of ideas. Over in this section, you've got all the concepts related to furriness. Way over there, you've got concepts for smiling. And moving smoothly from one point to another on this map means the final image changes smoothly too, like watching a face slowly morph from a smile to a frown. And here is the absolute craziest part, the thing that proves this map exists. Because all these concepts are organized so logically, you can actually do math with them. You can treat ideas like man or sunglasses like numbers that you can add and subtract. Let me walk you through a classic example of this. Researchers took a GAN that was trained on thousands and thousands of faces, and they found the exact spot on that conceptual map that represents man with sunglasses. Then, they did something that just sounds like science fiction. They took that concept, that vector, for man with sunglasses, and they mathematically subtracted the concept of man, and then they added the concept of woman. And what did the AI create? A perfect picture of a woman wearing sunglasses. Just think about that for a second. The AI didn't just memorize what sunglasses on men looked like. It isolated the pure idea of sunglasses and was able to apply it to a totally different concept, woman. So what does this actually prove? Well, it proves this is way more than just clever pixel mashing. It shows the AI has built its own internal, structured model of the world. It learned the fundamental patterns, what makes a face, and it can treat different features like gender or accessories as separate building blocks it can mix and match. And this quote really sums it up perfectly. The generator has managed to pull out these meaningful ideas from all the data, what it means to be a man or a woman, or to wear sunglasses, and it organized them in a way that makes sense, not just to a machine, but to us. It's a seriously impressive result. This amazing technology shows us that by making two fairly simple AIs compete, we can end up with something that genuinely learns, understands, and then creates. It leaves us with this huge, tantalizing question. If an AI can learn to understand our world visually, what other, more abstract concepts is it going to learn to create next?